The purpose of this video is to review question 3 of section B of the optional time trial. So question 3 includes some of what you just learned in terms of organic chemistry. So it's the very basic stuff. First thing, state the functional groups present in malic acid. So you have to understand that there's 2 carboxylic acid groups and an alcohol. That's all. Okay, at this point you have not learned about primary, secondary, tertiary alcohol, so we'll just ignore it. And always there's no need to identify alkanes. Okay? So, well, you can see the comments are, we ask for malic acid, you look at malic acid. Please, nothing to do with this. Very careless. And frequently, a lot of students, they blind, they see this, oh, there's a carbonyl. No. You have to take in this whole thing. When you see a carbonyl, you look to its left and right. Are there other groups over there that can change it? That means it's some other functional group. Be careful. Okay, it's not a ketone, for example. The last mistake, instead of saying alcohol, you say hydroxy. Not acceptable, because hydroxyl can mean both either alcohol or phenol. So this answer is not specific enough. We will not credit it. Okay, draw the enantiomers of malic acid. So you can probably figure out, oh, this is the chirocarbon. And this has been communicated before. You are supposed to draw it in a certain way. So this is one way to draw it. Please, you must include the bow, the wedge, and the, I don't know why they call it bow edge and zebra edge. I call it the dotted and the wedge. Okay, dotted line and the wedge. These two must be shown. Okay, if you draw it this way, say you draw it this way, because this is what a lot of students do. Okay, it's not wrong lah. It's just that it doesn't bring across the tetrahedral strongly enough. Will the examiner penalize? I don't know. Okay, but at least the most important, the dotted and the wedge are there. Okay, so you must have the dotted and the wedge. And of course, next you need a mirror line. Okay, then you mirror the structure. So you can see this is the example of the mirror line. You need to draw both enantiomers. You draw only one, no credit. Okay, the hydrogen needs to be shown, of course, because of 4 different groups. Okay, yeah. So again, we are asking for malic acid, not the other compound. So, well, just have to please read carefully. Okay, the next one is just pure memory. State one similarity and one difference in physical properties of the enantiomers. So very easy, you can just say they're the same. Melting point, boiling point, similar solubilities. Let's just say same, Same solubility in water, same electrical conductivity. These are the physical properties. Okay. Then the only difference in their physical properties, they rotate plane polarized light in different or opposite directions to the same extent. Okay, so you have to, this one you just have to die memorize. Okay. Take a while to pause and read through and look at the comments. So these are some of the common mistakes that we see in students' answers. I'm not going to pause here. You can pause. Okay, I'll move on. The moment you see this, furthermore, we already said the word kinetics. Oh, so this is actually a kinetics question. And you look at it, experiment 1, 2, 3, 4, 5. This continuous, straight up. You should recognize it. And this time we're very nice to you. We didn't even give you time. Then you have to calculate the rate from there. We give you the rate already, straight away. So what do you think you need to do next? Of course, the next step is to figure out the order of reaction with respect to each of these, right? Okay? But But before that, you realize we asked some definitions, so make sure to memorize these definitions correctly. Okay, so to be honest, this is just regurgitation. Regurgitate. If you cannot regurgitate, then skip lah. Go and do the things you can do. Now use the above data to deduce the order of reaction with respect to each of these reactants. Then construct a rate equation. Well, so this is back to the usual. So to find C3H4O3, you should realize, oh, I'll compare these two. Because HCN and NaCN are the same. Okay, I can write here 1 versus 2. Okay. How about HCN? HCN, let's see. 1 versus 3. Correct? How about NaCN? NaCN. Let's look at NaCN. Oh. You cannot use 5, because 5, this is an unknown. So 5 is for the moment out of play. 1, 2, 3, 4. Okay, realize, well, you can use any of these, but the problem is none of the other two will be constant, right? So now you have a problem. How? Can you use inspection? You realize the closest you get is maybe 2 and 4. Okay, 2 and 4, this is the same, but HCN and NaCN are different. Okay, but previously you already found, okay, you could have found order reaction with respect to HCN is how much. So actually you know it's order reaction. So what can you use? Then you have to realize, I cannot use inspection, I must use mathematical method. And you do it as the last step. So it's 2 versus 4, and you find this last. Okay, so let's do it. C3H4O3, 1 versus 2. Okay, then realize 3 over 4 times, 3 over 4 times. That's it, first order. Ta-da, finish. Second one, HCN, compare 1 and 3, increase 3 times, rate remains the same, 0 order, easy. Ta-da. Okay. The last one, NaCN, increase A over 5 times. The rate also increase A over 5 times. This is when you realize, hey, wait a minute, this is 0 order. You will actually, if you know how to explain, right, you don't even need to use mathematical method. You know this is 0 order already. So 0.1, if we put in the equation, and 0.4 to the power of 0, both of them equals to 1. So essentially, it doesn't even matter, right? So you look at this, oh, it increases 8 over 5 times. It increases 8 over 5 times. Oh, yeah, first order. If you realize this, you don't even need to use mathematical method. If you use mathematical method, nothing wrong. Definitely acceptable. Okay, but these are things, something you can use shortcut lah. Okay, so with this, we know it is first order with respect to the organic compound, and first order with respect to NaCN. Please remember, you need to say which experiments you are doing the comparison for. Okay? After that, calculate a value for the initial concentration of 3-oxopropanoic acid in experiment 5. So we take a look, experiment 5. Okay, let's clear everything. You take a look, experiment 5. This is the rate. Well, one thing that immediately strikes me are these values. Okay, both of them are the same rate. Okay, and you realize, oh, NaCN decreased by a certain percentage. So, in a way, you can consider, okay, we write out a rate equation, which we know already, right? Is 0.3 times 0.005. This is for experiment 2. Correct? And experiment 5, the rate is K, unknown. Okay, let's just do the X, 0.003. And you realize they both have the same initial rate. So in other words, you combine them, what can X be? I think it's very obvious, right? X must be 0.5 and just cancel out. You just do it in terms of proportion. Finish. That's it. This is really easy. It's a giveaway if you know what to do. Okay, done. Okay, the answer here we use experiment 4 and 5. Personally, I would actually use experiment 2 and 5 because they're the same rate. Life is easier that way. Okay, but no, regardless how you do it, you will get 0.5. Just make sure you use the correct units. No, the comments, there's no need to find the value of K. Okay, there are students who find the value of K and calculate, oh, very tedious. No need. You can just do it this way. Or what I did, which is even shorter, use the same rate. Done. Okay, based on the results from B part 2, state the value of the relative initial rate if the volume of the reaction mixture was doubled by the addition of water. Okay, so if the volume was doubled, you add water, the concentration of both will be halved. So the relative rate, half times half, it will be 1/4. Okay, so now the rate, they say experiment 4, let's go back, experiment 4 initially was 1. So it's decreased 4 times, it will become 0.25, and that is the answer we obtain. Last one, sorry, not last one, near the last one, but not quite. Okay, the following mechanism has been proposed. Is it consistent with the experimentally obtained rate equation? So you go back to the rate equation. Okay, there's the rate equation. So the slow step must have this organic compound, one molecule involved as a reactant, and NaCN involved as a reactant, so to speak. Okay, because Australian speaking, it's not really a reactant, they're actually more a catalyst. Okay, but it is involved in the left-hand side of the slow step. So, and only these two, cannot add anything else. So is that true in the proposed mechanism? Let's take a look. It's not NaCN by Cn minus. Is it the same thing? Actually, it means the same thing. Yes. So yes, it is consistent. Alright, so the order of reaction with respect to NaCN and C3H4O3, the organic compound, is the same as the stoichiometric efficiency in the slow step. That's it. Okay, you don't say they have the same ratio. That is not correct. Okay, it's not about ratio. So the reason is given here. If we say 2 is to 2, really it's 2 is to 2. Okay, so you cannot just base it on ratio. You say they must follow the stoichiometric ratio. Okay, based on the proposed mechanism in B part 4 suggests the role of Cn minus, you should realize it's a catalyst. It is used up and consumed in a reaction. It's consumed and regenerated. Okay, so consume the first step, regenerated in the second step, which is the fast step. Sketch a reaction pathway diagram based on the mechanism. So for this sort of reaction, if there are 2 steps, means there are 2 humps. For 2 humps, you draw this. Then a lot of students are, okay, how do I know the respective activation energies? Which one is higher, EA1 or EA2? Okay, so this is where sometimes the question doesn't give you any clue, but this time there is a clue. The first step is a slow step, so the EA must be higher. Because the activation energy is low, the rate will be faster, right? correct? So if the rate is slow, what does it imply about the activation energy? The activation energy is high. So indeed, this is what we see here. EA1 more than EA2. We have told you it's exothermic, delta H must be negative. Write down the reactants. These are the reactants plus the intermediate. Okay, you need to include the intermediate. Without the intermediate, catalyst, sorry. Without the catalyst, right, you cannot get the intermediate. It must be balanced at all steps, at all points. Okay, and this is the, in a way, the intermediate. And finally, the products. And of course, you realize, hey, wait a minute, the catalyst is regenerated. Okay? And with that, take a look at these points here. And hopefully, I hope this has been a useful learning session for you. Okay, we're done with this review. You may want to move on to the fourth video for additional tips on exam skills.